Hey everybody, Dr. Nelson here. The name of this video is One of These Things is Not Like the Others. Alright, so here's our scenario. It says a cookie company with a total of 4 stores takes pride in knowing that every cookie should taste exactly the same regardless of the location. Alright, so the owner of the cookie company franchise is monitoring the recipes used at the 4 different locations and spots an error made by one of the chefs. Okay, so what is the error? So let's take a look at this information. So store A, in order to make 100 cookies, they need 5 cups of sugar. Store B, in order to make 80 cookies, needs 4 cups of sugar. Store C, in order to make 120 cookies, needs 6 cups of sugar. And store D, in order to make 150 cookies, needs 15 cups of sugar. So here's my first question for you. Does one of these look a little bit different than the other? And we'll talk about why in a little bit. So let's try to figure out which one is different. All right. So in order to do that, we need to come up with the cookie to sugar ratio. All right. So basically what I'm going to do is I'm going to divide, okay, this first column by the second column. All right. So if I do 100 divided by 5, right, that gives us a ratio of for every 20 cookies, we need 1 cup of sugar. All right. Now for store B, if I do 80 divided by 4, right, that's also 20, right? So again, the ratio is for every 20 cookies, we need 1 cup of sugar. All right. Now, for store C, we have 120 cookies for 6. So again, if I do 120 divided by 6, that's also 20 to 1. And then finally, if I do 150 cookies divided by 15, well, that's different, right? 15 goes in 150 10 times. So the ratio is for every 10 cookies, you need 1 cup of sugar. So if you notice, these first 3 all have the same ratio of cookies to sugar, and this last one over here is different, right? So obviously store D has the mistake. But here's my question for you. All right, why would the cookies made at store D taste different than the other stores? How would it impact the taste? So think about it, okay? These other 3, to make 20 cookies, right, you need 1 cup of sugar. Right, and this one, to make 10 cup of cookies, you need 1 cup of sugar. So how would that impact the taste of store D, right? And the answer is, these cookies here would be way too sweet, all right? There'd be way too much sugar. It'd actually be twice as much sugar in these cookies, okay, as in store A, B, and C. All right, now here's our second problem. It says one of these shapes is different than the others. Okay, which shape is different and why? Okay, so here we have a rectangle with a length of 4 and a width of 2. Here we have a green rectangle with a length of 3, right, and a width of 1.5. And here we have a third rectangle that has a length of 6.6, right, and a width of 2.2. Now, in order to figure this out, we need to again to look at the ratios. All right, so I'm going to fill in all this table here to figure out the ratio of the length to the width. All right, so for shape A, I know that the length is 4 and that the width is 2. And when I do 4 divided by 2, I get a ratio of 2 to 1. All right, so the length is twice as big as the width. For shape B, I know the length is 3 and the width is 1.5. All right. And again, I know 3 divided by 1.5 is 2. So the ratio again is 2 to 1. Now let's take a look at shape C. Okay. Here I know the length is 6.6 and the width is 2.2. right? And I know that 6.6 divided by 2.2 is 3, right? So notice that the ratio, okay, of the third shape, okay, is different than the first two. So that means shape C is different than the others. All right, now with that said, there's a key term you gotta know. Actually, there's two key terms we're gonna review, okay? The first one is called proportional relationship. All right, notice it's in red, right? So if the ratios between two corresponding quantities are always equivalent, the relationship between the quantities is called a proportional relationship, okay? So let me show you what I'm talking about by that, all right? So if we go back to, say, the cookie problem, right here, all right? Notice the ratio of store A, B, and C were all the same, right? So store A, B, and C had a proportional relationship, but store D did not. All right? Going back to the problem with the rectangles, okay? Shape A and shape B had the same ratio, right? So A and B had a proportional relationship, where shape C did not. Finally, there's one more term you didn't know, okay? In a proportional relationship, the values for one quantity are each multiplied by the same number to get the values for the other quantity, okay? This number is called the constant of proportionality, all right? So let me show you what I'm talking about. Here's another table, all right? This column shows the number of hours, and this column shows the number of miles, say, traveled in a car, all right? To go from this column to this column, notice that we're multiplying by 50. So 1 times 50 gives you 50, right? 2 times 50 gives you 100. 3 times 50 gives you 150. 4 times 50 gives you 200, right? So 50, right, is the constant of proportionality of this table, right? Because in order to get this value, we always multiply this value by 50, all right? So let's say, for example, if we added another section here, we said in 10 hours, how far would we travel? Well, if we do 10 times 50, that'll give us 500. Because 50 is the constant of proportionality.